Now we're starting some problem solving using combination. So what will happen is I'll introduce two new formulas. Make sure you have these formulas on your study notes because they're important. People tend to, maybe because they don't stand out much, people tend to miss them, but they are very important, and you will be tested on those two formulas as well. Okay, but we'll talk about them in a few minutes. So this is problem solving. We'll review direct method and indirect method, and we'll take it from there. A delegation of 3 people is to be chosen from a group of community volunteers consisting of 4 lawyers, a minister, and 3 retail merchants. Oh, okay. So that's quite the committee. In how many ways can this group be formed if at least one retailer must be a member of the delegation? Use both the direct and indirect method to answer this question. So sometimes the direct method is easier and sometimes the indirect method is easier. You have to decide. Okay, it's on any test question, it will be your decision. Okay, I can't lead you one way or another. Or I won't be leading you one way or another. So we need 3 people on this delegation in total. Those are the key. Let's just get the key information here. So we have a delegation of 3 people, and they're going to be chosen from 4 lawyers, 1 minister, and 3 retail merchants. How many ways can this group be formed if there has to be at least 1 retailer? Okay, at least 1. So this is our key information. So notice we have 3 retailers, 5 non-retailers, right? And at least 1. So I'm going to do the direct method first. So the thing with the direct method is it's more work for one thing, but at least this question isn't that onerous. When there's at least 1 retailer, you have 3 cases. You could have 1 retailer, or 2 retailers, or 3 retailers, right? And we stop at 3 because it's a 3-member delegation. Okay, so in this case, we choose our 1 retailer out of the 3 retailers. Then there's 5 people left to choose from, and we need to choose 2 people from our non-retailers, right? 4 plus 1 is 5, in order to make up a group of 3. Or, so you remember or, it's the rule of sum, or that we taught at the beginning of this unit. Out of the 3 retailers, we can choose 2 retailers, and out of the 5 non-retailers, that's these guys, we need to choose 1 more for a total of 3. Or we can have 3 retailers, so we do 3 choose 3, and out of the non-retailers, we choose 0. And if you were to work that out, you would get 46 ways to choose this committee. Now the indirect method involves subtraction. What you could do is do total possibilities. I won't write out the whole thing because space, right? Minus 0 retailers, and then you'll have at least 1 retailer. Okay, so if you go two possibilities minus 0 retailers, you'll either have 1 or 2 or 3 retailers. So the total possibilities is 8, choose 3, right? So you have a total of 8 people to choose from. And if you choose 3 of them, that's your total possibilities. Now, out of the 3 retailers, we're going to choose 0 retailers. And out of the 5 remaining people, we choose 3. And that will give us our answer of 46. Wait, I'll trust you to put that in your calculator. And that's what you get. Okay? Oh, 20 people are to travel in a bus from the airport to the hotel at a resort. The bus is designed for use in a tropical climate. It can carry 12 passengers outside and 8 inside. So I'm going to draw a crude picture of this bus. You can have 8 inside. So I'm going to represent 1, 2, 3. Those are the 8 people inside. I'll show them like that. And then the ones outside I'll show out here. Okay, these are the outside people. It's just a crude picture to help us. So this is outside, this is outside, this is outside, and these people are inside. Okay? Just like that. 4 of the passengers refuse to travel outside. So 4 of them want the air conditioning. We'll put the 4 there. 5 will not travel inside, so we'll put them outside. And the other passengers don't care. So how can we take into account these wishes? We're just focusing on who's traveling inside, who's traveling outside. We're not worried about order at this point in time. We're not sure how they're arranged in the bus, so that order would be hard to answer in this situation anyway, so we'll just leave it at that. We'll just worry about placing the rest of the people. Notice that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? There's 11 more people to place. There's 20 people minus 1, 2, 3, 4, 5, 6, 7, 8, 9. So 20 minus 9 equals 11 more people to place. Okay. So why don't we place, we have 7 people to place outside, right? 1, 2, 3, 4, 5, 6, 7. So we'll place some people outside, and the remaining people will go inside. So this is for outside, and this is inside. And if we work that out, we get 330. Well, what if you place the inside people first? What would happen? Well, if I have 11 people and I put them inside first, right? There's 4 spots left for the inside. This is inside. And the remaining people, 7, choose 7, go outside. This is outside, right? Okay, we get 330. It doesn't matter. And in a future lesson, I will prove to you what is really, do you see really 4 choose 4 is 1, 7 choose 7 is 1. Notice that 11 choose 7 equals 11 choose 4. So what happens is n choose r equals n choose n minus r. And I will prove that to you in a lesson. So notice 11 choose 7 equals 11 choose 11 minus 7, which is 11 choose 4. So I will prove this formula in a future lesson. Okay. So that's what's happening here. It doesn't matter whether you place the outside people before the inside or the inside people before the outside. It doesn't matter, you get the same answer, which makes sense. Okay. A school librarian is purchasing books. Altogether, there have been requests from staff members. 3 people want Webster's Dictionary. 6 people want the manual. 2 people want Romeo and Juliet. What? Only 1 person wants History of Math? What's up with that? People have to get their priorities right. Because of budget restrictions, he may not be able to buy all of these. How many possible purchases could he make? Okay. So here we have, there's a demand for 3 copies of Webster's Dictionary, 6 copies of the English manual, 2 copies of Romeo and Juliet, and 1 copy of the math, History of Math. Okay. So notice they're not saying, well, how many ways can he make 3 purchases? Or how many ways can he make 10 purchases? We don't know. There's no specification of how many purchases he's going to make. We're just saying how many possible. We don't know for sure how many he's purchasing. Okay. So he could purchase 0 dictionaries, 1 dictionary, 2 dictionary, or 3 dictionaries, right? He could purchase 0 English manuals, 1 or 2 or 3 or 4 or 5 or 6. He could purchase 0 Romeo and Juliets, 1 Romeo and Juliet, or 2. He could purchase 0 History of Math books or 1. So can you see that the number of choices, total choices here, is 4? Or he could buy any number of these, and he could buy, notice there's 1, 2, 3, 4, 5, 6, 7 choices, right? Or he could have 3 choices, or he could have 2 choices. Now, because they're asking how many possible purchases can we make, we're subtracting 1 because he is making at least 1 purchase, okay? It's implied here, making at least 1 purchase is implied here. So we are subtracting the possibility of 0 purchases. So there are 167 possible purchases. So even though 3 people have asked to buy a dictionary, there's 3 plus 1 choices, which is 4. 6 people asked to buy a manual, 6 plus 1 equals 7. Do you see how you're always adding 1? 2 people asked for the History of Math. 1 person asked for History of Math. 1 plus 1 is 2. We're assuming at least 1 purchase, so we're subtracting the possibility of 0 purchases. And that equals 167 possible purchases. So the formula becomes the total number of selections which can be made. Notice total number of selections. We don't know if there's 3 purchases or 4. It's just some number of selections which can be made of P items of one kind, Q items of another, R items of another, and so on, is P plus 1 times Q plus 1 plus R plus 1, and so on, minus 1. 1 is subtracted to ensure at least one selection is made. So that's your formula when we don't know the number of selections to be made. Okay. A set with n distinct elements has 2 to the n subsets. And I'm going to illustrate this with an example. Okay? In this situation, 1 is not subtracted because the empty set is considered a subset of any set. So for example, if we have a set with 5 elements, let's say it's, I'll write it here. Let's say it's A, B, C, D, E. We have 5 elements, so let's say we have a set of five letters. How many subsets are possible with 5 letters? Well, you could pick 0 A's or 1 A, 0 B's or 1 B, 0 C's or 1 C, 0 D's or 1 D, 0 E's or 1 E. So there's 2 choices, 2 choices, 2 choices, 2 choices, 2 choices. So it just becomes an issue of 2 to the 5 equals 32. Or n here is equal to 5. So 2 to the 5 equals 32. Patty wants to throw coins in a fountain at the mall. In her pocket she has a penny, a nickel, a dime, and a quarter. How many different sums of money could she throw into the fountain? Okay, let's look at part A. She has 1 penny. She has a penny. We don't use pennies anymore. A nickel. A nickel is 5 cents. A dime is 10 cents. And a quarter is 25 cents. Okay, so you can either take 0 pennies or 1. These are your choices, right? 0 nickels or 1. 0 dimes or 1 dime. 0 quarters or 1. So in effect we have 2 times 2 times 2 times 2. She's going to throw something, so we subtract 1 to ensure there's not 0 items being thrown in, and this equals 15. Part B. How many different sums of money could she throw if she had 3 more pennies? So she has 4 pennies, 1 nickel, 1 dime, 1 quarter. Quarter. So here she has 5 choices. 4 plus 1 is 5. 1 plus 1 is 2. 0 dimes or 1 dime. There's 2 choices times 2 and minus 1. And this works out to be 5 times 8 is 40 minus 1 equals 39 different sums. Find the number of divisors of 100. Well, let's look at this. The number of divisors of 100. So what divides into 100 evenly? I'm just going to list them all, and then I'm going to show you a way to calculate it. Let's just list them all. 1 divides into 100 evenly, right? 2 divides into 150 times. 3, no. 4 divides into 125 times. 5 divides into 120 times. 10 divides into 110 times. 20 divides into 105 times. 25 divides into 104 times. 50 goes in twice and 100 goes in once. Notice there's 1, 2, 3, 4, 5, 6, 7, 8, 9 divisors of 100. How can we calculate that without having to list them all? First find the prime divisors of 100. Okay, so you know 100 equals 2 times 2 times 5 times 5. So 2 times 2 is 4 times 5 is 20 times 5 is 100. Notice these are all prime divisors of 100, or you could say these are all prime factors as well. Okay, so notice we could choose 0 2s, 1 2, or 2 2s. We could choose 0 5s, 1 5, or 2 5s. So we have 3 choices times 3 choices equals 9. There are 9 divisors. Yeah, the thing is, if we subtracted 1, we're going to have to add 1 for the divisor of 1, right? So we don't have to worry about subtracting. Okay. A few more questions. How many dance committees? Were there any other? Is there anything I can explain here? Are you comfortable in finding prime divisors? Right? Sometimes, maybe if you remember from grade school, if you want to get the prime factors of, say, 100, so you know that's 2 times 60, and you keep going, right? So that's the same as 3 times 20, and you can keep going. We'll leave the 2, that's already prime. 3 is prime. That's 4 times 5. So we keep the 2, keep the 3, and that's 2 times 2, and that's 5. So the prime divisors of 120 are 2 times 2 times 2 times 3 times 5. Right? So in this type of question, when you're finding the prime divisors, you can do that. Or the prime factors. And then you can work with them. How many divisors are there of 120? Well, there's 3 2s, so there's 4 choices. Two choices for the 3, right? 0 3s or 1 3. And then 2 choices for the 5. So for 120, there is 16 divisors. Right? But I won't list them all. Okay. How many dance committees of 5 students can be chosen in a school with 1,000 students if the committee must contain one particular student, Bob Smith? Okay, we have to include Bob Smith, so we choose Bob Smith, right? That's our Bob. Then out of the 999 people left, we need to choose 4 more for a total of 5, and that's approximately 4.125145625. It's a ridiculous number times 10 to the 10. How many dance committees of 5 students can be chosen in a school if the committee must not contain Bob? Oh, Bob cannot be included. They're isolating Bob for some reason. I wonder what Bob did. Anyway, 1,000 minus 1, we have 999 students left to choose from, and out of those we need 5. So 999 choose 5 equals 8 point, well, it's a very big, well, here I'll write it in 209, that's a 2, 0.39794 times 10 to the 12, and that's approximate. The next question is interesting because we're working with 9 numbers. Let me write them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to choose 7 of those numbers. Notice we're not choosing all 9 at a time. Must include 1, 2, 3. So we've got 3 here we must include, and then we have 1, 2, 3, 4, 5, 6 numbers left to choose from. 6 left, right? Now we're only taking 7. So out of the 3, we must choose 3, right? And out of the 6, we need 4 more for a total of 7. Notice I've chosen 7, but those 7 numbers can now be arranged. So notice we chose our 7 numbers and then we arranged them. So that equals 75,600. 75,600 permutations. So we chose the numbers first and then we arranged them. Any questions?